Okay, tonight's notes are on points of concurrency in triangles. So first of all, what is a point of concurrency? It's a point where three or more lines coincide, which is just a fancy word for intersect. So the place where three lines intersect is a point of concurrency. Okay, so there's 3 points of concurrency that are associated with triangles, 3 different types. They're created by special segments in triangles. So the difference between them has to do with the different type of segment that creates them. The first one is created by perpendicular bisectors, and perpendicular bisectors all intersect in the same place, and that's at the circumcenter. The second one is angle bisectors. There's 3 angle bisectors in any triangle because there's 3 angles, and they create the incenter. You got medians, which create the centroid, and altitudes that create the orthocenter. So let's start back with the perpendicular bisector. What is it? It's a segment that bisects another segment at exactly a 90-degree angle. So in this triangle here, what that means is because it bisected, this is congruent to this one is congruent to this one, and this guy over here is congruent to this one over here. Okay? So the 2 parts on each side are congruent to each other. All right? And they intersect at the circumcenter. On a right triangle, they intersect on the triangle itself because the midpoint of the hypotenuse is where they cross. In an obtuse triangle, they intersect outside because this does cross, but it can cross all the way through and go outside the triangle. The angle bisector is the segment that divides an angle into 2 equal smaller triangles, okay, or smaller angles, excuse me. So each of the 2 angles equal each other wherever they're created. You draw all 3 of them, one for each angle, and you have yourself the incenter. A median is a segment that starts at the midpoint of the line and connects it to the other vertex. It really doesn't matter what angle it's going off of. This does not have to be 90 degrees. As you can see right here, that's not a 90-degree angle. Right there is you're connecting the midpoint to the opposite angle. All right. And last is the altitude. This is the segment that tells you how high the triangle is. It's the height of the triangle. All right, so you start at any vertex and you come straight down the triangle at a 90-degree angle. So this is going to cross at 90 degrees. This is going to come straight down. So if this were extended out, it would cross at 90 degrees. If this side were extended out, this would cross at 90 degrees. Okay, so it's how high the triangle is. What I sent home with you tonight is this sheet right here. Okay, all this does is organize everything really nicely for you. Perpendicular bisector and its definition. Circumcenter is the point of concurrency it makes. For acute angle, it's inside. A right triangle, it's on. Obtuse, it's outside. Does the vertex work as the endpoint? Sometimes. All right, the circumcenter is the same distance from each of the vertices of the triangle. And then this is just where you would put a picture of one. All right, so this breaks all the information I just told you down for you. Okay, the only thing I didn't talk about was a special property. So again, we just said the circumcenter is the same distance from each of the vertices. So this point right here is the exact same distance from each of the angles. The incenter is the same distance from each of the 3 sides of the triangle. The centroid is 2/3 of the way across. So there's your centroid. So as you go across from the vertex to the other side, this is 2/3 of the line, and this is 1/3 of the line. We're going to have a lot of algebraic type problems on this one. And then the orthocenter really has no special property, but again, it's the height of the triangle.